think we're good to go. You guys, yeah?
One second.
All right. I'll introduce you guys while you're getting started then. Okay, excellent. So the next talk is called Visual Effect of Final Fantasy V, Concept, Environment, and Implementation. 15, sorry, my mistake. Indeed. We have two presenters, Isamu Hasegawa and Masahiko Koyama. Isamu is a senior programmer at Square Enix, and he's responsible for VFX and UI in Final Fantasy XV. He's also a secretary of Information Processing Society of Japan, the special interest group on software engineering. And Masahiko is a graduate of Keio University. He handled VFX production for movies and drama and participated in over 30 productions before joining Square Enix in 2012 as a TA and artist. Recently, he was lead artist for 3D Big Bang, a project which transformed the large mural created by Yoshitaka Amano into a 3D image. So with that, please begin.
Hello everyone, we are very happy to be here today. And thank you very much for all attending our talk. The title of this session is Visual Effects of Final Fantasy XV, Concept, Environment, and Implementation. Today, we want to talk about our latest title, Final Fantasy XV, which will shorten to FF15 from now on. Our team will hold a variety of sessions related to FF15 at SIGGRAPH 2016. There will be 5 talks in total on VFX, characters, AI animation, graphics, and environment. We will also present exhibits in real-time live and electronic theater. In this session, we would like to talk about VFX. Please feel free to listen in on the other sessions from our other team members. Now, here's the agenda for this session. In this session, we will explain the concept of effects in FF15 and the workflow we used. We will also use videos to explain our VFX expressions on the current hardware generation. Also, we would like to talk about some of the issues we had and how we solved those issues. Introduction. My name is Isamu Hasegawa, and I'm lead programmer for the real-time VFX system of FF15.
And my name is Masahiko Koyama. I am a VFX supervisor, and I designed the VFX used in FF15. So now I'd like to explain the workflow based on perspective on FF15 VFX designer. In FF15, I handle quality control of VFX, structuring the workflow, and creating the shaders. First, I'd like to explain our game. Final Fantasy is a Japanese RPG series that boasts a very long history. The player moves around in an environment with a dynamic day and night cycle and fluctuating weather. Therefore, the assets that we created for this game had to be made so they do not fail under any circumstances, anywhere or anytime. Although our title have always been set in the realm of fantasy, our proportion for this title was to first make it photorealistic and then add all the fantasy elements to that. This was our philosophy for the entire game. Throughout all this though, VFX in particular is a section where the additional fantasy elements are more pronounced. As well, for natural phenomena like fire, water, and smoke, we made it our goal to first create accurate data for them. And there are plenty of merits to create accurate data. In the past, we created data separately for each environmental situation. However, if you have one set of accurate data, it will reflect the environment change as well. For example, if you have accurate data for smoke diffusion, then there is no need to reproduce this data for indoors and outdoors. Since we are creating a game for next generation game devices like PS4 and Xbox One, the expectations are much higher. And in order to deliver this goal, concepts like physically based rendering and linear workflow were absolutely essential. These terms have become common expressions in games and films today, and our expression for FF15 was no exception, in that we created all the sections based on linear workflow. And what was extremely useful in VFX was high dynamic range. This is an approach that is indispensable for VFX sections, which handle luminous bodies. For example, even if the same color white is being shown on the monitor, by creating variances of luminance on the items being expressed, we are able to support fluctuating scene and camera AB as well. At the same time, we have to handle others other than luminous bodies such as smoke, fire, lighting, water, and explosions. Although it was an enormous challenge to try and raise the overall quality of each of these elements, we are able to succeed in all of them. In many ways, this was also the culmination of our persistence in using shaders based on linear workflow. Now I'd like to show you some concrete examples of VFX. First, what can be called the epitome of VFX, an explosion. This is basically created by applying consecutive textures for GPU particles. Diffusive element and emissive element are expressed collectively using one shader. Now, some other situations like magic and monster summoning. This is fantasy, but we made it look realistic. The expression water is indeed the culmination of physically based rendering and linear workflow technology. Water has to be specular, transparent, and refractive. And it is these three elements that were truly difficult expressed before the arrival of next-generation game devices. It is possible using two parameters, opacity and transparency, to maintain the specular aspect while lowering the transparency to simulate the translucency of water. But now, with the addition of the refractive element, we are able to truly express crystal clear water. We can't just simply create high-quality VFX without first having a structured workflow that puts an emphasis on efficiency. In order to do this, we have to prepare several presets with a certain degree of quality. If we put the artists in charge of creating assets from scratch, the individual variances among those artists would have led to an inconsistency of style. Due to these concerns, we had two people who sufficiently understood the framework start by creating a number of presets which would set the boundary within which artists could freely construct assets in a node-based system. As a result, we were able to maintain a high degree of quality and efficiently create data. In many ways, a shader can be called the ultimate preset. None of other designers apart from me understand its contents, but that is totally fine. Generally, designers prepare their parameters and manuals and came to me frequently with questions regarding their usage. When I wanted new functions, they came to confer with me and the programmers, and after taking into consideration process load, etc., these new functions would later be added on. Even node graphs, which are very complex, look fairly clean and organized when the parameters that comprise them are clustered. So I strive for something that was easy to use, while looking at other CG software for reference. The final movements and appearances are interested to the artists. By using node-based system, we are able to provide artists with the level of freedom they previously never had. At the same time, however, we are through our execution to make sure that each and every asset was created using the presets. I've discussed the general workflow so far, but now I'd like to explain more detail how images are created. Procedural content generation needs a technology that has existed for a long time in the images industry. And in FF15, a procedural technology that evolved from Houdini, etc., was implemented. It is used outside of VFX as well in things like weather, for example. Of course, not everything is procedure generated. There are many assets that use standard fixed textures as well. For example, if you try to create lens flare using textures, then you will most likely end up with a Mac band and a very heavy memory load. While this is standard in pre-rendering, we created a lens flare as well as combat effects in FF15 using procedure generation. The memory freed by our use of procedure generation was allotted to textures, since the memory allotted to VFX in FF15 was not so much. It could also be said that how we effectively made use of texturing was another matter of importance. This is especially true for parts that could not be supported by individual textures, procedure textures, or standard UV scroll use consecutive textures. Consecutive textures are an indispensable element of textures when expressing things like explosions and water. By using the consecutive of normal maps, in addition to the standard alpha consecutives, we are able to attain an even more realistic form of expression, especially with the elements like water, where the specular map is involved. Consecutive normal mapping played a highly effective role. These textures are created using the existing dynamics of Hume, fluid, and Bifrost, etc. As well, when creating the shader, since composite software like FFXV and Nuke are being used, it could be said that knowledge of VFX has become indispensable for both games development and movies. It goes without saying that the workflow for big title like FF15 requires solid rules. In order to bring expressions of next generation to life, the leadership of people with pre-rendering knowledge is indispensable. Therefore, before we started production, we thoroughly implemented a workflow in which a few members laid down a set of rules first, and then made sure that the other designers run those rules. Especially for designers who specialize in real time, there are so many new things to learn. This learning curve that was perhaps the biggest issue at the beginning. However, in time, their level of knowledge began to increase, and their compatibility with node-based design and real-time VFX began to produce very good results. As a go, the programmer would like to follow up on this point.
I'd like to explain about the development environment of the node-based effect systems implemented in FF15, its merits and the issues we face, and how we counter those issues. Perhaps one of the biggest characteristics of node-based tools is that they facilitate componentization. This means that a component can be created as a node graph by combining nodes. And furthermore, that node graph can be handled in the same manner as other nodes. We learned that this characteristic was extremely compatible with our workflow. When Koyama mentioned the important framework is created by knowledgeable people, he is referring to the work of combining nodes and creating node graphs as a component. And as long as the other artists can learn the minimum rules to use those components, this will then allow them to go into the development. This is the second point. In this way, it can be said that node-based and the development of large-scale effects is extremely compatible. However, there are several issues in the development of this node-based effects environment. When we began implementing VFX editor and runtime, we thought that everything would go without issue, because at the time, we already had many examples of node-based development tools. However, in actuality, we hardly had any tools that had the three characteristics of real-time, effects, and node-based that our VFX editor and runtime were equipped with. For example, Houdini is not normally used for a real-time game, and Unreal Blueprint does not handle effect either. So why is it so difficult to produce real-time effects in a node-based system? In order to explain this, I first have to go into the nature of effects. As you may be aware, effects are characterized by their high volume but short lifespan. In this video, a variety of effects like heat, smoke are being generated. Here you can see a large volume is created and then extinguished after only a few frames. illustrating this high-volume short-life paradigm. This high-volume short-life trait is peculiar to VFX assets and is the biggest obstacle when creating node-based tools. When you naively think about implementing node-based effects, the individual elements of effects like sprites, shaders, and its matrix operations, for example, becomes the instances of the nodes. However, when you think about the high-volume short-life characteristics that I just mentioned, handling high volume of effects elements results in creating large numbers of node instances, and therefore negatively impacts memory performance. As well, handling elements with short lifespan entails that repeated creation and destruction of these node instances in a short time frame, and therefore result in negatively impact to processing speed. Regarding the memory and processing speed performance issues, as I just mentioned, I would like to introduce two ways that we were able to counter those problems: grouping and formulation of nodes. At first, about grouping. Usually, in a node-based execution environment, individual node instances have independent life cycles. However, when handling effects, the life cycle of each node is not completely independent and can be grouped to a certain degree. For example, when taking into consideration a sprite, its shader, and its matrix operation, there is not really need to individually administer the life cycle of each node. However, by securely grouping these related nodes together, we could create and destroy them collectively. As a result, we were able to simplify a variety of processes, and that is why things like memory allocation and release were not handled per node, but together as a group. That is also why the release of links between nodes removed together at once. Since most links are connecting nodes in the same group, the effect of simplifying these node links was quite significant. Then, about formulation. We classify nodes into two types: simple nodes and complex nodes. Simple nodes are nodes that don't possess their own state and only output the results calculated from the input. For example, nodes that conduct basic arithmetic operations are simple nodes, whereas complex nodes possess their own state and, in many cases, update on each frame like drawing. For example, nodes that accompany drawing like sprite and models are complex nodes. Through our experience, we realized that when creating effects with node-based tools, the majority of the nodes are simple nodes. Here, since these simple nodes do not possess state, there is essentially no need to create instances. As a result, in VFX Editor, by grouping simple nodes and converting them into one larger simple node, the memory and processing cost that is incurred by the creation destruction is optimized. We call this formulation. The group of nodes prior to formulation represents more than one calculation. The partial nodes formulated are nodes that evaluate this calculation. By executing interpreter for the evaluation of this formula in development, we are striving to reduce the development iteration. However, by additionally converting it to C++ code during the asset building time, it can be further optimized in the final product. Now, I would like to wrap up this session. We've demonstrated that the effects in FFXV were based on photorealism, and from that starting point, accurate data was created. We adopted concepts like PBR, linear workflow, HDR, EV, as well. In order to efficiently implement next-generation expressions, we actively sought to integrate procedural expressions, and by using the remaining memory for the consecutive textures like normal maps. As well, to maintain quality and construct an efficient workflow, TAs will create shaders and presets, and artists have to use them without editing the contents. With this concept, we can keep our data consistent. As a result, we were able to develop a node-based VFX environment to support this workflow. Since our environment handles real-time VFX, its compatibility with VFX characteristics like high volume, short life was poor. And so we developed certain countermeasures to solve these issues. In this session, we introduced two of those countermeasures, the grouping of nodes and formulations. That wraps up our presentation, visual effects of Final Fantasy XV, concept, environment, and implementation. Thank you very much to everyone for listening.
Once again, there's some time for questions from the audience if anyone would like. There are microphones in the aisle. No one at this time? All right, yeah, come on up, Oliver. Thank you very much, guys.